Okay, let's get up and running. We want to install Visual Studio Code. That's where we're going to be writing all our code. Go to code.visualstudio.com or just simply Google Visual Studio Code and make sure it says Visual Studio Code in the top left corner, and then you want to download and install Visual Studio Code. I'm on Windows, so download for Windows, but they have a Mac version and a Linux version as well, so you can download it for your relevant OS. Once that's downloaded, run the installer and install that. And then let's go to Nodejs.org next. And you want to install Node. Again, install it for your OS. I'm using Windows, so I'm downloading it and installing it for Windows x64. But under downloads, you can see they have a Mac OS installer and installers for Linux as well. So download and install Node.js. And once that is done, open Visual Studio Code. So once you've opened Visual Studio Code, let's go and view our terminal. So click View and Terminal. And we just want to double check that Node is installed successfully. So if we just do a node-v, this will tell us our Node version. And as long as you've got this version number or higher, you should be good to go for the rest of the course. Okay, so let's get started with this project. So if we click on View and Terminal, if you don't already have a terminal open, let's create a folder for our new project. So I am going to put my project on my D drive in a folder I've already created called Web, and then I'm going to make a folder, make directory called single phase, which stands for single player phaser game. So let's create that folder, and then if I cd into that folder, and now I want to open this folder in Visual Studio Code. So the easiest way to do this is to just type in code -r, which means that it will open in this already open instance of Visual Code, and then a full stop. So if we do that, that opens our folder single phase. So that's closed our terminal, so let's just open our terminal up again. Let's initialize our project using npm init, and we can say that we just want a whole load of defaults by doing a -y. And as you can see, that has created a package.json file, which if we click on, we can see that it's given us a whole load of defaults, and I'm kind of happy with these. Our main JavaScript file is going to be index.js. It's set up a test line for us, but we're not going to worry about that. And I'm just going to add in an author of Morgan. So if you put your own name in there and then Control S to save. Let's carry on and create this index.js file. So we can click on New File here, or right click and do New File. So we're going to start off with creating a simple web server in Node.js. Now the very easiest way of doing that is to use a package called Express. So if we bring up the Express website, so if you go to express.js.com, you see that it's a web framework for Node.js. Handily, it tells us how to install it using the Node Package Manager, npm. And then if we go to the Getting Started page, it actually does a lot of the steps that we've already done. But if we click on Hello World, we can see we have a code snippet here which will get us up and running with a web server. So let's select all that, right click, do copy, and go back to our index.js file and paste that in. So let's just quickly go through what this is doing. So require is a way of loading modules, so other bits of JavaScript code. So we pull in the Express module. We essentially instantiate that the Express and assign that to app. We specify the port that we're going to use later on for listening. So with Express you can set up routes very simply. So we set up a route here for our root, R-O-O-T, and so if someone goes to the root of our server, we will send back hello world. And the final thing we have to do is we have to tell Express that we want to listen on port 3000. This is just what will essentially output to say yes, we have started the web server and now we are listening on this port. So it's a very quick overview of what this code does. So if we save that, Control S, and now if you remember we need to actually install Express, so we can simply do that by doing npm and then I for install and then Express. So we've installed Express and now we should be able to run this code by typing node space index.js. Now we got an error, and so let's just expand this and see what this error says. So it quite clearly says the address is already in use, which probably means that I have a server already running somewhere. So let me just check that. Yep, I've got a server running elsewhere on the screen. So that might happen to you as well, so that's kind of handy to have hit that error. If you've got multiple windows open and you're running multiple node servers, that can happen. So let's try again. So if we do up arrow and we're successful this time, example app listening on port 3000. Okay, so we have a web server listening on that port. So let's see if it actually works. So if we bring up our browser and we type in localhost 3000, then as you can see we have our hello world here, which is being served up with this line here. Okay, so we have our Express server working, but we don't want to serve up just hello world. We actually want to serve up a HTML file that's going to contain our game. So let's create a folder called public, which is where we're going to put all our game files. And then within that public folder, let's create a file called index.html. So let's create some basic HTML in here. So we can actually use Emmet if we have Emmet installed. Just type doc and then tab, and that will actually fill out HTML page template for us. And let's change our title here to say single player phaser game, and then in our body, just so we can see if this is working, we will copy our title and we'll paste that within our h1 tags. So now we want to serve up this index.html file. So if we go back to index.js, instead of sending hello world, we actually want to send a file to the browser. So we can change this to send file, and all we need to do is specify the file name in here. So the safest way to do this is to use a global variable that Node gives us called directory name, and that will give us back the directory that we're actually running this particular module in. So we know that relative from this index.js file, we need to go into the public folder and serve up this index.html file. So if we save that, and we will actually need to stop and start our server, so if we come down to our terminal, click in here, and to stop the server we just do Control-C, and then restart it again by doing up arrow and return. So now let's bring back our browser window and do a refresh, and this is a pretty handy error because it's telling us exactly what it can't find. So we're missing a slash here, so let's just go back to our code, and sure enough, yes, we haven't got a slash in there, so put a slash in, save, stop the server, Control-C, start the server, up arrow, return, go back to our browser, do a refresh, and now we're using Express to serve up our HTML file. So we have our basic HTML page being served up by our Express server, but now we want to start using Phaser. So the easiest way to get started with Phaser is to use a CDN, or Content Delivery Network. So if we bring up our browser and we search for CDN Phaser, and we can choose the top link here, and we have a CDN that's serving up Phaser arcade-physics.min.js, which is the one we want. So if we copy that and go back to our code, so we want to bring that in via script tag. So if we type in script source equals, and then if we paste like so, and then close our script tag, then that has brought Phaser into our HTML page. And then we want to first of all specify where on our page we want to place our Phaser game. So I'm going to place it under the title, and so we specify a div, and I'm going to give it an ID of Phaser game, and that's where Phaser will place our game. And at the bottom here I'm going to specify our script that we're going to put all our game code in. So I'm going to put all our game code in a JS folder, and let's call our game singlephase.js. So that's going to be our entry into our game, and let's save that. So let's create this JS folder. So we want to click on here, do new folder, and call this JS. That needs to be under the public folder. And then inside this JS folder we're going to create a new file, and we're going to call this singlephase.js. Now I'm going to paste some code in here just to save a bit of time, but you can obviously pause the video and type this all in. But let me just go through quickly what this is doing. So this is creating a game space which is 640 pixels wide by 640 pixels high. We're using Phaser to decide automatically what type of game space we're going to use, whether it's going to be Canvas or WebGL. Now this is the an important bit, because this is where it's going to place the game. So if you remember, we created a div with an ID of phaser game. So this basically says I'm going to stick the game underneath that div. And this is where we're going to define our scenes, but at the moment we haven't got any scenes, so we're just going to have an empty array here. And then we're going to create our phaser game with new phaser game and then pass it this config constant. Double check we've got everything we need here. I think that's looking correct. So let's go back to our browser. Let's close this now. And if we refresh, we see nothing is happening. So let's debug this. So if you right click and do inspect and then go to our console, we can see that for some reason Express is having problems finding this single phase.js file. And that's to be expected actually, because we need to make a slight change to our Express code. So at the moment Express is only serving up this one file, but we actually need to tell Express where we're keeping all our static files. So let me just paste in the code that we need for that. So this is simply telling Express all our static files will be in this public folder. And now actually we can simplify this line here, because now we're telling Express this. We can just say send the index.html file, and since this is in the public folder, Express will find it quite happily. So let's save that, and we need to stop and start the server. So Control C, up arrow, node index.js, hit return. Let's go back to our browser. Let's do a refresh, and as you can see now we have our game space here where we can start creating our game inside here. Okay, so now we want to create our main scene, which is going to hold our snake game. So let's right click on the JS folder and let's call this main scene.js. So create a file there called main scene.js. Create a class called main scene, and this extends the phaser class called scene. Now classes always need to have a constructor, so let's create a constructor. We actually have to call super with the name of our scene, so we're going to call this main scene. Now the phaser scene class has a few methods set up for us. So that it has a preload method, which we're not going to use. It has a create method, which is handy for getting things started when the scene first opens, and we also have an update method, which is essentially where we want to do all our gameplay stuff, because this gets called over and over again. So the update method takes a time and a delta. We're only going to be interested in the time. What do we want to do in this main scene? Well, let's first of all check that this works. So if we console log and let's just throw update to the console, so hopefully if update is getting called over and over again, we should see this tick up. So we need to specify that we're going to use this main scene in here. So to make that available, first of all we need to export it. So that will export main scene. So let's save that, and then if we go back to single phase, we want to specify that we are using main scene, and we want to import main scene from our main scene.js file. And let's go back to our browser and do a refresh. And it says import declarations may only appear at the top level or module, which is entirely correct. So we're using this import at the top of singlephase.js, but we haven't specified in index.html that we are using modules. So we do that by doing type equal module. So if we save that and go back and do a refresh, now it is happier. And we can see that update is indeed getting called over and over again. That's ticking up. So we know that our scene is getting used in our game. We're going to create a snake game. So funnily enough, the snake game has snakes in. So well, it just has one snake in, and let's create a snake class, seeing as we're doing this all using modern JavaScript. Let's do it with classes. We're importing snake here, and probably what we're going to want to do is create an instant of our snake when the scene starts, and we're probably going to have, let's get rid of this, we're probably going to have a method on snake, and let's call it update for consistency, and we're going to send it the time. So we're going to have an update method on our snake that we're going to call every time step. So now all we need to do is create this snake.js file. Okay, so let's create our snake.js file. So if we right click on the JS folder, choose new file, and we're going to call this snake.js. We want to create a class called snake. Let's export this class so that it's available to the rest of our program. And we want to always create a constructor. So we're going to pass in a scene to our constructor. If we click back to main scene, we can see that we're creating the snake and passing in this, which is the actual scene itself. So that will be super handy. So here we're creating a scene property and assigning it the scene that we've passed in to the object. Now it's pretty nice to see something immediately. So let's write some code that's going to show something on the screen. So how we do that is we add game objects to the scene, and so we can add a rectangle, and let's just put it at say 10, 10, and we're gonna make it 16 by 16 pixels. And then we need to specify a color in a hexadecimal format. So it's RGB, so that's the byte for R, which is red, and the other 2 bytes will set to 0. And then if we save that, So we should be able to go back to our window now and refresh. And of course we've forgotten to add the update method, because we're actually calling that, so let's just put in a blank update method for the moment. And if I remember rightly, it takes a time, so let's just put that in as well, and we'll save that. And then if we refresh, we see that we've got a red rectangle here. Now if we actually place the rectangle at 0, 0 and refresh, we see we're only seeing a part of that rectangle or square that we're outputting to the scene. But actually we want, at 0, 0, we want to show the whole square, and that's because by default Phaser sets the origin of every game object to its center, and we actually want it to be in the top left corner, so we can easily do that by doing set origin with a 0. And then if we refresh that, then now we're showing that rectangle or that square correctly at 0, 0. Now if this was just a box that we wanted to move around the screen, instead of a snake, we could just assign this rectangle to a property, say we call it box, and then in the update method we could say something along the lines of this dot box dot x plus equals say 1, and then if we save that and go back and refresh, we'll start to see this red box moving across the screen. So it's as simple as that to get something moving in Phaser, which is great. Now of course a snake is not just one box, it's actually going to be it'll start off as one box, but then as we start eating apples, if you know the game Snake, the length of the snake will increase, so we actually want to add a box every time we eat an apple. So what that feels like is that the snake has a body, and that body is an array of boxes. And so this is how we define an empty array. And then if we want to add this box that we've just created to this body, we can just type in this body dot push and push it onto the array like that. And so instead of doing this dot box now, this would be this dot body, and it's at the it's the first element of the array, so that should still work. So let's, for fun, let's just copy this line and make 2 boxes that we add to the body. And let's make this a, well, it's RGB. So let's make the B byte FF. Everything else 0. So we should have a blue box now. Let's just see what that looks like. And of course that makes sense. Although we've added the box to our array, we're only moving the first part of the body, but we're not moving the tail part of the body. So the head goes shooting off and the tail gets left behind. So let's not worry about that at the moment. It'll be quite nice to be able to move this at least the head around. So let's do that now. So the way we do that is we need to set up inputs on this scene. We need to basically specify that we're interested in the key down input from the keyboard, and we can assign that to a function. So let's do that now. So we say scene.input.keyboard on, and here we just say that we're interested in the key down event. And then what we can do is we can use a nifty little arrow function here to call a method called this dot key down and send it the event. So now every time we hit any key on our keyboard, we'll get a key down event, and that will call the method this.keyDown and send it the event information for that key, which we can use to work out which key's been pressed. So let's just see if this works now. So if we actually create a key down method, we're sending it the event, and let's just console.log the event to see what that looks like. So let's save that and let's go to our browser, and if we refresh and let's so if we hit the left arrow key, up arrow key, right arrow key, down arrow key, you can see that we get an event listed here, and we can use the key code here to work out what key is being pressed. So let's type in our switch statement. So we're looking for the key code here, and if the key code is 37, which we saw was left, we want to do something. Let's put a break in here and put the colon in the wrong place. That was silly of me. So do that, and let's just copy and paste this. 1, 2, 3, save. And it's 38, which is right. 39. No, 38 is up. 39 is right. And 40 is most definitely down. Okay, so let's have a think about this. So depending on what key they press, we want to change the direction of our snake. So that sounds like we want a property called direction. So let's create a property called direction here. And what will this be? Well, we want it to be a vector, because vectors are great at pointing in different directions. That's kind of what they're made for. So let's do that. So Phaser has a handy little vector library, so let's do that. So essentially we've assigned the direction to left. Let's make it right for the moment, we can change it later. So how do we use this? Well, here we can simply do this dot direction dot x, copy that line, and then in the y direction simply use the y part of the vector. So this is the x part of the vector, this is y. And I mean, what it's doing is the right vector is simply going to be 1, 0, and so it's going to do exactly what we were doing a moment ago, which is adding 1 to x and 0 to y. So that's kind of nice and simple to understand, hopefully. Let's just see if that works. So if I go back to and refresh, there you go. So let's just prove that point, because it's kind of hard to see that actually happened. So let's make this going to the left, and let's make our rectangle say start at 100, 100, so we can actually see it. And then if we refresh, there you go, shooting to the left now. And I don't think I have to prove to you that up and down works. Well, let's do it. So down, and refresh. There you go, down. Right. So we want to change this vector depending on the key. So now hopefully you can see that that's actually really easy to do, because we just take that line. We've got down already written for us. Let's paste it in there, and that's left. Paste that in there. That is up. Paste that in there. And that is right. So left up, right down. Yeah. Okay. So let's save that. Refresh. So it's going to work. Right arrow key, left arrow key, up arrow key, down arrow key. So we've got basic movement of the snake head. Working quite nicely. Okay, so we've got the basic movement of the snake going, but actually, if you know anything about the snake game, it doesn't move smoothly across the screen like this is doing. No. What it does is it jumps by essentially the size of its body. So let's do that. So how do we do that? Well, we're moving by 1 pixel at the moment, and actually we want to move by the size of the square. So we'll hard code this in for the moment. It's a bit naughty, but we'll sort that out later. So if we do that and refresh, now that's working. But it's super fast, obviously, and we need control of that. So we don't want to move as fast as that. So there's various ways of getting around this, but probably the easiest to understand is to create a move method that we only call a lot slower than what our update method is getting called out. And actually, we want to. I mean, we want regular movement, so we want the snake to move at a regular pace. And so that's why this time is handy, because we can sort of say, oh, just move every second or move every half second. We've got time here, you know. That's all we need to be able to work that out. So probably what we want is we want to remember the last time we were moved, and we want to define our move interval. You know, how how often do we want to move? Do we want to move every second, every 2 seconds, every half a second? And then we've got a variable there that we can, it's actually going to be a property, that we can change, have a play around with, so we can speed and slow down the snake as we see fit. So let's sort that out now. So if we do this dot last move time, really nice and easy to understand. This is the time in milliseconds that we last called the move function, that we last moved. I'm going to set it initially to 0. And then we're going to also create a property called move interval. And we're going to say let's move every second. So like I said, time is actually in milliseconds in phases, so 1,000 milliseconds is a second, so our move interval is a second. So now we want to move this code here into our move method, so let's cut that out of there and paste that into there. And so now we just need to make sure that we call that move method at the appropriate time. So how do we do that? If time is greater or equal to the last time we moved plus the time interval, move interval, then that sounds like the right time to move. But before we move, let's just remember to reset our move time. Actually, you want to set it to the time that we've moved, because that is the last time we moved. So, and then let's move. So it reads like English. It's pretty easy to understand, I think. So I think that's all we need. So let's save that and let's see if that works. So let's do a refresh. And that looks pretty good. And then if I go right, our snake starts to move right. Press up, our snake starts to move up. And if we change that to say every half a second, 500 milliseconds, hit save, go back, and there you go. We got more of a snake-like movement there. Okay, so let's address the elephant in the room, which is that our poor snake, its head shoots off, but it's leaving its tail behind. So how do we fix that? Well, our head, we've decided is at body 0. It's the first element in the array, and our tail at the moment, which is the only other part of the body we've got, is the second element of the array, or the last element of the array. They're the same. So what we want to do is we can sort of hack it here. It's not going to be our final solution, but you'll see how it kind of works. So what we want to do is say, well, we know the tail is here, and we just want to assign that to where the head was, and we know the head is here. .x, and copy that because I'm lazy, and y. So let's save that. Let's just quickly. So we've got, this is the tail, because we've pushed this onto our array, which adds it to the end of the array. So this is element 0, this is element 1, because arrays start at 0, so 0, 1. So this is our tail. This is the X position. This is our X position of our tail. We want to assign that to our current head position. And the same with the Y. And then here we're going to move the head to a new position. So let's just see if that works. So if I save this, go back to our game, refresh, and there you go. We have our tail dutifully following us around. So that's the general idea, but we need to get this to work when we add more segments to our body. We have 2 segments at the moment, so if we had a third segment, we just need to essentially copy this and do that. I hope that makes sense. If we've got 3 segments, our tail is actually in the is the third element. So it's at index 2. This is our middle of our body. And so we just want to keep doing this. So we want really a for loop that kind of encapsulates this idea, and can do it no matter how many segments of our body we've got. So let's just try and reproduce this in a for loop now. So if we do for, and let's call this index. So where do we want to start? Well, we want to start we know we can get the length of an array with the length property, but that's going to be, well, let's just get rid of this line. Let's just do it. Let's just work our ways logically through this scenario where we've just got 2 segments of the body. So we have a length of 2 here, but we want this number, so it's got to be -1. The final index, the last segment of our body, is always going to be at index length -1. So that sorts that out. We want to do the assignments for all the body parts apart from the 0 one, because actually we're going to do this never changes. These 2 lines are always, the head always just forges forwards. It's the rest of the body that we need to deal with in this for loop. So we're going through the array kind of backwards. And what we want to do is this dot body index. Let's just be lazy. Let's just do this and copy this. Copy this. And we know this is going to be index. Index, and this is going to be index -1. Okay, so we can delete this now because we're doing this in the for loop, and we can move this down to here. Let's save that. Let's see if that works. So great, that's working, but will it work if we add another segment? Well, let's just do that up here. And let's make this white. So let's turn on our RG and RB. So FF. Save. Refresh. And there you go. We have a red, white and blue snake. Very patriotic. Okay, so we have our red, white and blue snake working now. But we only want to start off with the head of the snake. So let's delete these two body parts. And now we actually want to place an apple in the scene so that the snake can eat the apple and grow its body. So I'm a bit fed up of having these 16s lying around, so let's fix that now. I'm just going to add a tile size property, and I can essentially use that wherever I'm talking about the width and the height of our rectangles. We want to place an apple in the scene. Again, this is going to be a rectangle, but it's going to be a green rectangle. But let's do this now. So let's say we want an apple, and we want to add this to the scene. So we add a rectangle, and for the moment I'm just going to place it at 0, 0. We can use our new tile size for the width and the height, and we want this apple to be green. We want red to be 0, green to be fully on, blue to be 0, and then of course we want to set this origin to 0 like we always do. And so we've added our apple here. So let's just see if this works. So we'll save that, switch to our game, and we have an apple in the top left corner. Of course we don't want the apple in the top left corner, we want it to randomly spawn somewhere in this game space. So let's create a method to do that. Let's cheekily call it before we create it, so that we don't forget to call it. So we want something like position apple to place the apple in a random position, and let's create that now. Now we want to set the position of the apple, so that will be done by setting the X and the Y of the apple. We know that that would place it in the top left corner. So you may be tempted to do something along the lines of math.random, which will give you a number between 0 and 1. And then if you simply multiply that by the width for the game window, which we can get from our config, config.width, and we can do the same, copy and paste, change that to height. And if we save that, go back to our game, you see that that works. But the trouble is that we should be sticking to a grid of 16 by 16 pixels. And actually I noticed up here that we're actually starting our snake not on that grid. So we should fix that immediately. So we really want to stick the snake right in the middle of the scene. And we're making a presumption here that we're going to create our game window as a multiple of 16, which is perhaps something you can't really presume if you want to be pedantic about it, but we'll live with it. So this needs to be divided by 2. And it's not the scene, it's this dot scene. Okay, so hopefully our snake is on the grid now, but our apple certainly isn't, because we're just multiplying our width by a random number, so there's no reason at all why that should be a multiple of 16. So to make it a multiple of 16, we'll need to times it by our grid, our tile size, which is 16. So let's do that. Do that here. But of course this number is going to be too big now. So we are going to want to divide by 16. So let's divide by 16. And let's just make sure we're always dealing with integers, so let's floor this. And let's do the same down here. Save. So what this is doing is getting us a random number between 0 and actually I can see here that I've got my brackets in the wrong place here, because I actually want, let's just move these. Save. So what I want is I want a random number between 0 and the width divided by tile size 16. That will give me a float, possibly. So I want to floor that to make sure I get an integer. And then if I times that by 16, then I know that this random number going into x will always be a multiple of 16. And doing the same here as well. So hopefully the math all works out. Let's check it out. Well, first of all, let's make sure the snake is on the grid, which it looks like it is. It's right hard up against the side there. Now let's see if this is also on the grid. Yeah, that apple is on the grid. as you can see. So let's refresh again. And again, the apple is on the grid. Third time's the charm. Yeah. So that's great. So we have good placement of our apple now in our game scene. Okay, so we have good placement of our apple, but we're not doing anything with it. We're not eating it and growing our length. So let's fix that now. So to eat the apple, we need to compare where the snake's head is to where the apple is. And if the two are the same, then we've eaten the apple. So we're doing this as part of the move, and so we need to test where the apple is compared to where the head's just moved to. So we need to know where the head is moving to. So we want to stick this in a local variable. So we know that our head is going to be moving to here, and we're getting rid of these 16s now, and we're using tile size. So this is where our head is going to be after it's moved. So we don't need to do these lines anymore. We can replace these lines with this. So now let's test for if we eat the apple. So we are comparing the apple's x to x, and the apple's y to y. And if this happens, then we've eaten the apple. So what do we do when we eat the apple? We increase our body size. Well, we know how to do that because we do this, and we were doing it up here. So let's do that. So we can say this dot body dot push, and we want to add to the scene a rectangle, and for the moment we'll put it at 0, 0. Again, we're getting rid of our 16s and using tile size. And let's make the rest of our body. For clarity, I'm going to call the rest of our body, i.e. excluding the head, the tail. Just because it makes it a little bit easier to talk about. So we're going to make our tail white. So we do that, and then we just need to set our origin to 0, 0. And that will eat the apple and increase the body size. And then if you think about it, we've eaten the apple, so the apple needs to be repositioned. Well, we've got a handy little method for that called position apple. Okay, let's save that and see how we've done. And let's slow the snake down so we can see that a little bit clearer. Oh, we'll get there eventually. So that's working perfectly. And if you made it this far, then well done. We're really getting there now. Unfortunately, it is time for our snake to die. So let's check for the demise of the snake. Okay, so if our head has gone off our screen to the left, then we're dead. Or our head has gone off the screen to our right, we're dead. Or our head has gone off the top of the screen, we're dead. Or our head has gone off the bottom of our screen, we're dead. Oh, so many ways to die. Let's just check over this. So if we've gone too far to the left, if we've gone too far to the right, if we've gone off the top, gone off the bottom, yeah, we are dead. What do we want to do when we die? Well, you know, we could show up a game over screen and all that sort of stuff, but let's keep things simple. And what we'll do is we will restart. We'll restart the scene, which essentially will reload this whole scene and reset everything to start conditions. Let's save that and see if that indeed works. Let's make ourselves a little bit faster. So let's say 400, just so we move around a little bit but we can see what's happening. Go back to our game, reset. So we're testing going off the bottom now. Yeah, we've reset. Let's test going off the top. Yes, we've reset. Let's go to the right. Yes, we reset. Let's test going to the left. Yes, we reset. Okay, so we have one of our def conditions done. So let's be good little coders and just comment here that this was def by going off screen. Now, what's the other def condition? This is def by eating own tail. So how do we check for this? We check if our head position is equal to any of our tail positions. So we know that our tail is everything except the head. So we essentially want an array of our body parts minus our head. Tail is equal to, and the way we can get back a piece of an array is of course by slicing it. So how slice works is you put in a start index and an end index, but you can miss the end index out, and it will always go to the end of the array. So that's ideal, isn't it? Because we want to start, we know our head is at 0, so we want to start at 1 and go to the end, and that's our tail. Simple as. Perfect, we have our tail. Now then, what's a cool way of testing to see whether our head position correlates with any of those tail positions? We can use an array method. There's some really cool ones. Let's use, well, filter is probably the easiest to understand, so let's use that. So if we do tail, filter, and we're going to test every section of our tail. Let's have S for square or section, or however you want to think about it. So for every square in our tail, we want to see, okay, is that at the same position as our head? Well, we know that our head is always at body 0, so that's testing our X position. And we do the same with the Y position. So what does filter do? So filter essentially will pass back the array that we're running it on, which is tail. So if you remember, tail has everything except the head. So filter is going to go through the whole of our tail, checking to see if this is true. And if it's true, it's going to pass back that element of the array. So we get an array back from here, so we need to check the length of that array. And of course, if this is true and we do get something back, then we know we've eaten part of our tail. And so we're checking for that array being greater than 0. And then of course we're doing our def thing, which is this.scene.restart. So let's save that. Now we don't want to sort of faff around trying to eat the apple and seeing if this works. Let's add some segments to our body immediately so that we can test if this works. So again, we can do that up here by just copying and pasting this a couple of times. Well, we probably want to paste it like 5 or 6 times just to make it easy to eat our own tail. So, and let's make them white. And so let's paste this, say 1, 2, 3, 4 times. Right, let's go back to our game. Let's restart. So now we have our snake. Let's see if we can eat our tail. So up, up, up. There you go, we ate our tail and we reset. So it seems to be, oh, we didn't quite eat our tail there. Yeah. Oh, no, we just missed it. Yeah. Okay, so we've got that working. There's actually another one to use other than filter, which is actually even better, because it will just essentially return a true or false depending on whether this returns true. So this essentially does the same thing as filter, but instead of sending back the array, the parts of the array that match this criteria, it just sort of says, is there any part of that array that matches that criteria, which is exactly what we want. So we can do tail sum, and then we don't need to, it doesn't pass back an array, it's just true or false, so we can get rid of this bit here. So let's see if that works. And again it does. So even simpler solution. And it's nice because you've kind of learnt a couple of array methods. Okay, so let's tidy up our code, seeing as we did a lot of pasting of body parts up here, which we obviously don't need. So let's go and delete all these. And let's make our move interval a more player friendly 100. Let's go back to our game, do reset. Oh, it's a hard place for the apple to be. So as you saw, we just kind of died there, and that's because if you go back on yourself, actually you need another segment for that to work. Okay, let me actually just try and if I go back on myself, then of course I die immediately because I'm eating my tail. Well, that's sort of not quite what we want. We want to avoid people when they're going right. We want to stop them from going left. So you can't do this or this. So that's really pretty simple thing to do. So let's do that now. Okay, so we only want to allow going left if we are not going right. So we just need to put in an if statement here. So we can say something along the lines of, if this dot direction is not equal to phasor dot math dot vector 2 dot right, then we allow the assignment of direction to left. So if we take this if statement and we paste this down here, so this is going up, so if we're going down we don't want to allow that. Paste it in here, so we're going right, so if we're going left we don't want to allow that. Paste this in here. If we're going up, then we don't want to allow that. So let's check that. So if we want to go left, we can't be going right. If we want to go up, we can't be going down. If we're going right, left, down, up. Okay, let's test that. So I'm going up, I can't go down. I'm going left, I can't go right. Going down, can't go up. So that looks good. So in theory we shouldn't be able to kill ourselves by just going back on ourselves, which we can't. So unfortunately we've come to the end of our little course. I hope you've found it interesting and informative. Our snake game essentially works. It's missing some niceties. It's missing a start screen, missing things like sound and some effects and a game over screen. The apple doesn't test whether it's going to spawn on top of the snake. So there's a few bits and pieces that we could add to improve the game, but essentially it's working. And if you got this far, then you should be super proud, especially if you haven't written a game before. because you've got a playable game here that actually you could show someone and say, hey, look, I made this. And you've made it fully in JavaScript using modern techniques like classes and array methods and modules. You've learned a little bit of Node.js on the way. And that's about it for this course. Thanks very much for participating. Hopefully see you in one of my other courses.